Good morning, everyone. My name is Stephanie Nissen. I work with Elastic, and I oversee Elastic for Students and Educator program. So we're excited to be here again. We were here just a month or two ago, and we hope to continue this in the spring as well. Just kind of sharing a little bit about Elastic and hopefully information that's relevant to you and your research. And everything, and hopefully being a resource. So I just want to talk just a little bit about the Students and Educator program. If you were here last time, you probably got the same spiel, but if you're new or maybe didn't take advantage of it, I definitely want to reiterate what we're here to do. So this is a new program to Elastic, but really just focused on providing support, product access, and helping students and educators to utilize Elastic to diversify their skill set, to improve their research, and really take that and bring it out into industry with them. So we are an arm of community, so we are all about kind of free and open and providing you with what you need to be successful. So some of the things that we do, obviously access to Elastic Cloud. I've included here just a QR code. As a student or an educator, if you're listening, you have access to 30 days, so an extended trial of Elastic Cloud for free. So you can really kind of get in there and start using it. We also, provide free training and support, both through our training center at Elastic, through on-demand courses, but through events like this, through, workshops and presentations and in-class events. So we're always open to kind of how can we help you to kind of, build up your skill set and learn a little bit more about Elastic. We also, obviously are with, the community team. And so we connect and network with the community. So we really are focused on bringing students and educators into our community that spans the globe that Phoebe will talk about in a second. But really it's a growing network. It's, amazing to kind of utilize, especially during a time where everything is virtual. You have access to, not only the people within the network, but all of the resources as well. And so we really kind of want to spread that and make sure that students and educators are aware of that and start to kind of build those bridges. So I did just include some information about where you can find more info, but of course you can, and I'll put my email in the chat as well. And so you can of course just reach out to me directly. We're here to kind of support you if you're working with Elastic on a research project, or you want to share a little bit about your experience, or you want to maybe get a little bit of support. We're here to really talk about how we can do that for you. So don't hesitate to reach out. And now I'm just going to turn it over to Phoebe, who's just going to talk a little bit about the Elastic community at large.
Thanks, Stephanie. Hi, everyone. My name is Phoebe. As Stephanie mentioned, she, Emanuil, and I are all part of a team called the community team. And this term is thrown around a lot these days, community. But for us, what it really means is that we are an open source company, and that we are really devoted to sharing not just our code, but how to use our code. We want to try and help folks understand and be aware of Elastic and how to understand how to use it. So we participate in a lot of different communities besides just the Elastic community, but basically, we can be found at technology conferences. We also do our own tour, the ElasticCon tour, which we just recently held. It's open and free, and you can get access to lots of different sessions about different technical aspects of the Elastic Stack. You can also find us at meetups and forums. We have a forum called Discuss Forum, and I'll be sharing links to all of these in the chat. And then we also have a community YouTube channel. This is where we record all of our meetups, and then we share them in a library out on YouTube. And if you want to head to the next slide, Stephanie. So we currently have about, I think, 140 different user groups all across the globe, and that's about 80,000 members of people using Elastic and interested in talking about Elastic. And there are about 40 of those in the United States right now. And so if you just go to meetup.com or you go to the Elastic website, you can easily find a user group in your area. And this is the place, this slide in particular, if you want to use your phone and grab with a QR code these links. I'll also share them in the chat, but these are links to our Elastic meetups for the Americas region. And then also we have a community Slack workspace. This is open and free to anyone who's interested in talking about the Elastic Stack. And there are channels inside of that workspace for every one of our solutions. So if you're interested in machine learning, there's one on machine learning. If you're interested in security, there's also a place to talk about that. And then also our community YouTube channel, as I mentioned before. So moving on down, here are some of those links that I mentioned. Again, don't expect you to try and grab them off this slide. I'll throw them into the chat. But just to give you a sense of all the resources that we have available for you, you can hit our forum. This is a great place to ask technical questions. You can hit our website, which has tons of information, our documentation, if you're trying to go through the technical aspects of a solution, and then the Elasticon tour, as I mentioned. Our training, where if you want to take more formalized training with us and get certified, you can become a certified Elastic engineer, and then the community YouTube channel. I think that is pretty much it for me. We would love for you to join our community. We love having new people come in. We're always looking for folks who want to talk about Elastic. If you're interested at all at speaking at a meetup or sharing a project that you're working on, we'd love to hear about it. So we'll put our email in the chat as well.
Yeah, thanks, Phoebe. And I am going to be turning it over to Emanuil. If you missed his last session, this is Emanuil, who is one of our developer advocates with Elastic, based in London or in the UK. And so he'll be kind of continuing this series, hopefully into the spring. Really just lucky to have him to talk a little bit more about machine learning, and happy to answer any questions that you have. You can put them in the chat while he's talking for anything community, but I don't want to waste any more of his time. So I'm going to turn it over to Emanuil, and we'll start putting some info in the chat for you.
Hi folks, welcome to Outlier Detection in the Elastic Stack. Oh, let's get started. So today we'll be talking about outlier detection only, so not anomaly detection, although the stack is definitely capable of that. Actually, we'll talk a little bit about what the machine learning module was designed for in a second. But today will be just outlier detection and some useful ways in which you can then use the data and present it to people. Because what I see that something that happens quite often is people will do some analysis or some massaging of data, and that includes machine learning in the Elastic Stack, and then they're not actually aware of how to present it, and that's quite an important part of doing data analysis. And the presentation part of the tooling is actually completely free, so you can use this with any data sets, with any features that you have and that you want to highlight. So basically, we'll do a little bit of analysis, and then we'll build a dashboard together. Yeah, so let's get started, because it's quite a lot. So first off, if you've not heard of the Elastic Stack before, really quickly, or Elastic, the company behind the Elastic Stack, and essentially we're a company that was founded around an open source analytics and search engine, which is still at the heart of the stack, and that's called Elasticsearch right there in the middle. And it's basically you could throw numbers or text at it, and it will find answers to your questions really quickly when you ask them. It's a NoSQL data store, and it uses indexing very heavily. In fact, we're a traditional database, you might use maybe a few dozen indices, maybe 2 or 3 per table. Everything in Elasticsearch is an index, so the data comes in as secured 100 different ways with different indexing techniques, so you can then find it really, really quickly. It's also quite good for time series data, which we actually won't be looking at today because I want to focus on just outliers. But if you're doing anomaly detection, then the time series abilities will be pretty relevant to you, because usually people want to build a model and look at anomalies over time. And some of the other useful stuff that we have might be less relevant to you, as Beats and Logstash. Those are for web monitoring. These are like taking logs and metrics about servers, computers, and so on. and sending them off to Elasticsearch where they can be viewed. We have some open source project, but there are many commercial use cases, and those pieces of software, which are also free, support one of those major use cases, which is web monitoring and observability. But today we'll be using mostly Elasticsearch, of course, to store the data, and the machine learning module that it has, and then also be using Kibana a lot. That's just a graphical user interface for Elasticsearch. And you can use the data store without it, but you can't visualize things so easily without it. So. And then you can use it, all of the software, in a couple of different ways. It's important to mention. So one is Elastic Cloud, which Stephanie mentioned. And I would, especially for you folks, I would recommend going that way because everything is set up and you don't have to take care of the cluster and the software once it's running. But if you did want to, just so that you are aware, you can download all of this and play with it yourselves. It is a lot less relevant for machine learning because the machine learning module is commercial. I'll explain a bit more in a second. But if you want to just do visualization, like what I'm about to show you, or if you want to use it generally for data science, like for storing data, you can actually have a look at the last talk when we published the video. Then you can download all of this and use it for free yourselves. However, for machine learning, your best bet is Elastic Cloud, like by far. You'll see why shortly. So in general, like what is the point of, like what are we trying to do with the ML module, and what's the aim, what's the audience? So we saw that several years ago that there were a lot of different tools that people had to put together to do, well, machine learning. And of course, this stack, this is like a gold standard. Obviously, you can switch out some of the components. Like you don't have to use pandas for massaging data in Python. You don't have to use scikit-learn for testing and evaluating models. A lot of people do use Spark for productionizing their stuff, but you don't have to necessarily do it exactly like this. It's just that the point is there's a lot of different components, and that makes for a really flexible environment. But what we noticed was that there are certain things where we could operationalize this a lot better because, well, you see how many different components there are here, and very often they involve Python. So you have to have some skill in Python, and you have to have tried these different libraries, and Spark only really starts making sense after you use it with like a bunch of data in production. So not everyone is really in the spot where they can do that. And we had a lot of other audiences, like system administrators, site reliability engineers, who might not have the exposure, might not have the time to look into all that. And so we decided initially for them to build this machine learning module. And so the idea here is that the machine learning module itself does the analysis of data. There is a little part of it that will help you with ingesting data as well, but there you are mostly on your own. Like Elastic has ingest and transformation capabilities to some extent, but for example, if you wanted to do data cleaning, basically you'll need a Jupyter notebook, and I'm going to show you that as part of the demo today. But then once you have your data in Elasticsearch, then you can visualize it using Kibana, and you can look for some like just initial patterns and what the fields are. And we'll actually do that today. Then you can do analytics, like outlier detection, which I'll do today, or you can do anomaly detection, and those are the two unsupervised types. Then we've also introduced some supervised learning. And then essentially from then on, you do inference, and you can transform the end result in various ways. So overall, the idea is that this is a stack that allows you to just do machine learning quickly on a data set that you already have in Elasticsearch. It's less flexible, so like there is a trade-off, of course. It's not like, oh yeah, we're this amazing vendor, everything is great. The trade-off between like this setup with lots of custom parts and this setup is that the Elastic setup is it's best suited to specific use cases, And like outlier detection, anomaly detection already give you a huge range. But like your data has to be in Elasticsearch, for example. And you can't really train custom multidimensional models, like just to do random classification, for example, because that's what you decided to do one day to explore your data. So you have to kind of more stick with things that we have available. But on the other hand, it's a lot faster. So if you wanted to put this in production, you don't have to build out the whole pipeline. So that's the trick. All right, so we've already talked, there's unsupervised anomaly detection and outlier detection. We'll look at outlier detection today, but there's also supervised stuff. Just so that you know about it, we do, for example, language identification. That's our sort of first a proper multi-class classification use case. That's working very well. And we're already being used for fraud detection and financial institutions and user classification. Those are a little bit harder to set up, but that's just to give you some feel for what is possible. For those, of course, you need to label your data, so like supervised learning. Right. So, all right, let's get into it because I have quite a long demo today. So what we're going to do is we're going to use Airbnb data from inside Airbnb.com. And we are going to basically look for good deals of where to stay after the pandemic is over. So we're going to start with cleaning and uploading the data to Elasticsearch. And then we're going to do a bit of outlier detecting and then a bit of dashboarding and visualizing. All right, so first off, Elastic Cloud. So definitely the recommended way. See exactly why in a second. So this is what you see when you log in, and you'll want to hit create deployment, and you just want Elastic Stack. The default configuration is fine. You don't have to care about any of that. I was wondering which region to pick for this, and like Texas is kind of smack bang in the middle of the country. So I'm going to just stick with the default one. You also want to leave the highest currently available version, which is 7.10. That's what I'll be showing you today. And you can give it your own name. Now, for the trial especially, for production, you probably want to set the RAM to something like 4 or 8 gigs, and you definitely want at least 2 availability zones. You can start adding more nodes once you max out the RAM. You can increase beyond like 1 node per zone. So, but for playing, like for you, if you want to play with the trial, set it to 1 gig of RAM and 1 fault zone, 1 availability zone. You will be fine. Nothing bad will happen. Of course, don't put data that you can't afford to lose. Obviously, that's why the warning is there. But leave everything at minimum. Disable APM because you will really not be needing that. And add a machine learning node. Leave the RAM at minimum, and again, just 1 zone. Now, why is this like by far the best way to use machine learning and like try it out? It's because it's part of the trial, and it's not part of the trial if you download it. So you need an actual commercial license if you download the software, and it's not piecemeal like cloud, like hourly or whatever. You need like a commercial subscription to use the machine learning features, and you have to pay per node, and they are pretty expensive, at least compared to free. So that's why definitely go for Elastic Cloud trial for this. All right, and then you hit create deployment. Once you do that, don't worry, we're not going to wait through the whole thing setting itself up. Once you do that, it will show you a password. Copy that because it'll only show that to you once, although you can reset it at any time. So not such a big deal. Now, I have one set up, so let's have a look. The only thing here really, like after it's all set up, is you just hit here, open Kibana or Kibana launch, either way. And you will get into Kibana. And then it will tell you, first you need data. Okay, right, excellent. So let's get into data. So now we have an empty Elasticsearch instance and empty machine learning node. That's all we got. Okay, so I won't go through this in like a whole lot of detail because assuming you've seen a notebook before, we also saw one in the previous session on data science. We're just using pandas and NumPy to get in a CSV and delete some columns, like normalize the values in some columns. We'll see what we're doing there. All right, so we read in the CSV, and these are the kinds of things that we got in there. So they're Airbnb properties, right? All listed on their website. So how many people does each property accommodate? For how long, like in the future, how many days of the coming 1 year is the property available for? That's kind of, you might think it's kind of weird, but we will use that to filter out later on properties who are, like not listed basically. They're on there, but they're not available within a year. So what's the point? And neighborhood, latitude and longitude, URL to the property, type, bedrooms, and price. I think these are probably the most interesting things. We do a bit of cleaning, so when you've got like not a number, we'll assume at least one bedroom and yeah, one bathroom, one bedroom. I drop some values. Okay, so we convert the price to a float here, like again, because it might have $sign and so on. These are for New York City, by the way. This is American data, all homegrown. Okay, we have a sanity check. That's more for me. Yes, okay, all of the records I expect are in there. All right, so we've loaded in a CSV. That's not too interesting. Now, this part here is where it gets a little bit more interesting for you. So we have a schema here. Now, Elasticsearch takes semi-structured data, so you can do without a schema, but it will just guess the schema. And that's actually fine. Like for things like integers and floats and text, it's okay. But you will very likely very quickly want to start defining a schema. And yeah, especially folks like you who are interested in data science and machine learning, you should just go ahead and write down your fields. It's a bit boring, but it'll pay off. So specifically here, it'll be super useful because you remember how we had latitude and longitude as columns in the CSV? So here, we're going to put them together in one field called location. And then that allows us to actually put them on a map. And if we don't have the schema, we don't do a little bit of data massaging to put them in one field, then they will just be floats, positive and negative float, but not so useful. I think there's probably not anything. Oh yeah, the timestamp field, that's just when the document came in. So you can actually have Elasticsearch stamp that for you. You can, of course, generate it in here if you like, but I thought it would be good to show you how to do that because it's a little bit of processing. Once you know how to do that very simple bit of processing, you can do other kinds of processing as the data comes in. Elasticsearch has tons of different, we call them ingest processors. That's what you need to Google when you're looking for this. And so here we'll use the one that just stamps the record. Okay, so let's define the mappings. So I've written like a very simple generator in Python. Really the only thing it does is it formats it a little bit more nicely ready for bulk upload. So this is a form that if you go to the JSON object like this, where it has like underscore index and then an underscore source, it has like the overall record, then this makes it ready for bulk upload into Elasticsearch, which is a lot faster. And the Elasticsearch Python client has a helper function that makes this trivial. And even with a 1 gig RAM node, it'll be really quick. And here we massage the latitude and longitude into one field called location with 2 keys, lat and long, rather than having 2 separate latitude and longitude fields. Okay, I can define that, start talking to Elasticsearch. Okay, this is just for me to check that the index doesn't already exist, which it shouldn't, because I prepared the instance and everything is fine. Okay, so now we want to create that index. Okay, now we've done that. Right, so here we've got that timestamp thing that I was talking to you about. So we will define something called timestamp pipeline, and that's a timestamp processor. Now, the relevant thing here is when we define the index, we also tell it to use that pipeline. Okay, so find the index, put the schema in there, and we put the name of the timestamp pipeline or whatever processing pipeline you're going to want to use. And then after we create the index, we can create the pipeline. And here it is. Now every document will be timestamped. Okay, and so this here, helpers.bulk. So helpers is actually being imported from the Elasticsearch Python client, elasticsearch-py on Python. And from helpers, we have this bulk function, and it will basically like batch up records from the generator. We'll create lists in memory of 500 and send them off. And then off it goes. All right, so. We do not have to wait for that. So, right, so let's just go on to discover in Kibana. Okay, all right, so that's the next step. Initially, you open it, it'll tell you, you have no data, there's nothing, you should put some data in. So now you put some data in, then if you click on the discover link again, and it'll tell you, you have data, you need an. Okay, so you need to create an index pattern. So what do you need an index pattern for? Well, that'll be much clearer later. But basically, this is, it tells Kibana what the structure is, what the schema is, and it allows Kibana to do things like auto-completing fields, auto-completing values, just being very helpful overall, and doing automatic like date histograms, which we'll see in really just a second. And you can pick also the time field on which to sort of to be the main time field. You can do timestamp for when the records were added. Like right now, it'll be pretty boring because it'll be the last couple seconds. Here we have, in this data, we actually have some other interesting stuff, like since when the host of that listing was a host, like it has been a host on Airbnb. So I might get an interesting little visualization out of that. Okay, so we have a pattern, and then we go to discover, where we look at data in Kibana. Okay, so because we picked host since, there have been no new hosts added to the data in the last 15 minutes. And I happen to know that we want 14 years, or like that's the whole date range. Maybe there's a problem. All right, let's have a look. Let's complain about that in the data. Why not? Of course, this worked perfectly on my 2 trial runs. Okay, well, you get to do a bit of diagnostics. It just looks like perhaps I missed to run. Missed to run the conversion into data frame. Yeah, that would definitely do it. All right, let's just rerun everything above this cell. Okay. Okay, so that data set is now in memory. We don't really have to redefine the generator. Let's trash the index. See, this is why that line is there. Let's recreate it. I think the pipeline should still be in there. Yeah, okay. Create again. Okay, this time we're gonna watch it. Actually, I can show you how to look at it, in case you do need to debug an issue like this. Right, if you, on the sidebar, go to Dev Tools, and you will be able, it will autocomplete your index of Airbnb listings, and you can then do count like that. Now we'll show you the current number of docs. Okay, 26,000. This is going better. 29. There are about 42,000, so we'll be done in a second. And yeah, this is pretty useful here. This is if you want to talk to Elasticsearch directly. Something else that's cool is you can just do underscore search, because we won't really be using this today. Okay, we're done. Great. And I just realized that I did on the wrong screen. Okay, so what you do if you want to diagnose this is you go on the sidebar, DevTools, and in the console, you just type the name of your index and then underscore count, and you can see the number go up. Alrighty. So back to Discover, last 14 years. Drum roll. Aha, that's better. Okay, so this is when people became hosts. So it's quite an interesting histogram just right off the bat, and that's something that I wanted to show you. That's what an index pattern allows you to do in Kibana. And it's already, you can do this, of course, for any date field, and it's already quite useful. See times when it was more popular to become an Airbnb host and how things leveled off severely in the beginning of 2020. All right, okay, so then on we go. There's something that I want to show you here very quickly, just to do it how we display stuff. So what you can do here is you can also make this a tabular display, which is pretty, I know it's basic in machine learning, but it's important to know how to do this kind of thing as well. There you go. So here, and I don't know, maybe number of bedrooms. Yeah, because then when you're needing to diagnose something and it's not working out the way you expect, you need to know how to use the UI. Like, it doesn't take long, a few seconds to learn, but okay, right, excellent. So let's move on to machine learning, finally. Have a look at the data set first. So if you have, before you run the actual analytics task, if you have a data set and you've uploaded it already, what you can do is use this data visualizer thing in machine learning. And what it'll do is it'll just show you either top values or the distribution of values. So for example, here's the distribution of the price. So there are a lot more properties between $100 and $115 than anything else, which is quite useful. And you can just see this like straight up directly. Here are some top values for text field. So the vast majority are their home or a private room. So there's very, very few hotels. And this is just like a quick overview, the most properties will accommodate 2 people. That's quite an interesting distribution chart. Right, so onwards we go. Machine learning, we want, for outlier detection, we want a data frame analytics job, because you can do regression, classification, or outlier detection. So let's do outlier detection. Right, what we're doing for time. I will usually show you how to do a job and then clean it up, but I think, given the time, I am just going to show you how to create clean data. Okay. Right. So basically, one thing that would happen here when we run this, like if you look at the data, there's a bunch with. This makes a lot more sense. I'll show you in Discover. Last 15 years. Okay. If I set the price to exactly 1, there's quite a few records like that, and they're going to show up as anomalies. I just usually show that to you via an analytics job, but in the interest of time, I'll just, because I know what's in the data. But the interesting question is, okay, what can you do about this? If you detect a thing like that, you would run another job, and very simple, just set a higher price. Now, I've also picked a few other criteria, number of reviews, and if you remember, I was telling you about that availability over the next calendar year. So we're gonna set availability to over 0 as well. And then you have to hit enter. Right. Now that's the query, it's been saved. Okay, and then we want to pick what fields will be analyzed, and I just want number of bedrooms, people it accommodates, because those could be unusual, especially together. I don't care about IDs. The price is interesting. Yeah, that's it. That's what I'm gonna pick. Okay. We have a whole gig of RAM, so we can go wild. You can generally just leave this at the default value. It would very likely be okay. So leave everything as is. Just give it a name and start it. Okay, sometimes it doesn't immediately refresh, so then I like to just go to the jobs, because the jobs have a refresh button. And oh, yeah, phase 3. And you can see details about the job, including like the messages, a full log of stuff, so you'll be able to see errors and exactly where we are. So first it will reindex all of the source data, so it doesn't screw up the original data. Then that's just loading it, like as in loading into machine learning core memory, into the machine learning node. Then actual analysis of the outliers, and then it just writes out the results to the target index, which will be the same as the job ID. So the new index is called demo outliers clean. Okay, excellent. So, right, so we've done that. So let's have a look at what we can do with those outliers. First off, just to give you a quick idea of what the result that actually is. No timestamp field, so we won't get to the histogram. Okay, so the records look much the same, but we now have we now have a machine learning outlier score. So that'll be how weird is this listing, and we can do a lot of interesting things with that. All right, so if we go to the dashboards, create a new dashboard, and let's give it a name. And you'll likely want to store the time in this case, because you want to be seeing the last 14 years of records. That's if you use any of the originals. In the case of the outliers, there's no timestamp field, so you're fine. Edit. Okay. To create a new visualization. All right, so I'll show you the first interesting thing, and that's the lens type visualization. So of course you can do like with visualize. Let's actually go to have a look properly at the different types first. So with visualize, you can do your normal area charts, like heat map, bar charts, horizontal, vertical, lines for trends. There's geographical map, which we use, pie chart, which I know all the data scientists laugh at. You can do all of that, but lens, there you have to know what exactly we want for x-axis, y-axis, and so on. And lens is a bit more interesting. So with lens, you could just drag fields and see what happens. So for example, if we, let's say, we wanted to like break stuff down by the outlier score, by how weird the unsupervised ML module thought it was. Then if we do bedrooms, okay, so this is like the number of bedrooms on average compared to how weird is that listing, right? So really strange listings, 21 bedrooms on average. I suspect that's not very many listings. It's probably just a couple. But down here, it is more interesting. So there is maybe a little bit like just the weirdest of records, the outliers, but there's not it like the module hasn't inferred by looking at influencing variables and comparing between bedrooms accommodating the number of people accommodated and price. It hasn't really decided that bedrooms are that important on their own, which is interesting to know. Now you could do a further breakdown here. For example, property type. There's a okay, so this gets a bit more complex. As you can see, lens automatically suggests an appropriate visualization type. You can, of course, change it right here. But that's what I quite like about it. It's just a way to play around a bit more. And I think that's fantastic for a new data set you're trying to apply ML to. Okay, so here the weirdest records are all entire flats. Definitely is the case. And then we get a little bit of private rooms. But then the kind of less odd records, you get much more variety of, okay, those are private rooms. I have no idea what Casa Particular is. I guess this is like one record. This should already give you quite a good idea. Like if you had a text field that you wanted to see, okay, I didn't put this as part of the analysis, but is there any correlation at all? And this is a really useful technique, using lens to quickly have a look. Right, so let's move on. More interesting stuff. Lens. So that's sort of a visualization of what's weird. Okay, so now it would be good to see an actual display of the records that are odd. Just like here, I filter them by price. And let's discover this discover tab was opened before I ran the ML job, so just need a quick refresh. And there it shows up. Okay, so in order to add just a display, like a table, like we did at the beginning with the different fields being toggled into existence, into the display, we need to first save a search. So we need a saved search. So let's decide what we're going to want to display. But personally, I am going to want the outlier score, because when they're outliers, that's what's super interesting. Then the variables I asked to be analyzed. So price, bedrooms, number of people it accommodates. Then the URL would be quite useful on a display like this, because, well, we can just click at them. Maybe the property type. Maybe also the neighborhood, but it is a dashboard. We don't want to overload it either. Okay, so we've got this. Now we can save this as a search. And save search of outliers. Okay. We can add that here. There we go. The thing is, it's super bare bones, right? So the outlier score, yeah, it's displayed, but I mean, I might as well be looking at the CSV. This link is not clickable. It's not super useful, but we are looking at Kibana, not at Jupyter Notebook, or indeed CSV directly. So we can actually do something about this. In the very beginning, I told you that index patterns would come in useful in Kibana, and now is the time for them to shine. So if we go from the right-hand side menu to stack management, and then down below to Kibana index patterns, we can pick the outliers index, and here we can pick our fields. So let's change the outlier score, for example. We can format it in a lot of different ways, but let's do color. So for example, between 0.8 and 0.9, we can keep the text color, but let's like do quite a light highlight. That's not such a weird record. Then between, or we could just say 0.9, it's easier. Between 0.9 and 0.95, for example, we can do slightly heavier color. And 0.95 is already considered, okay, that's quite a weird record. So between 0.95 and 1, which pretty much never happens, we can set this. Okay. Then the other thing that we said could be interesting is the listing URL, which is here. And you can literally just say URL. You can also truncate the string or do a lookup from like basically to translate from static vocabulary. So you would have to enter the quotes here. Yeah, well, you just set it to URL and you hit save. And that's it. Okay, so now if we refresh our dashboard, it will become a little bit more useful. I didn't have to save it, but Kibana remembers. Okay, so here you go. Now we can open URLs directly, and to see the other bit, just start typing outlier score, and let's say I want them over 0.8. Yeah, and indeed, here we are. So this is now a lot easier to read. Okay. Now on to some even more interesting uses of outlier detection. Save that. And let's do here. I want to just do a new visualization map. Okay. So all of our documents are already in. Let's add the pure listings first. Set to the last 15 minutes. Set it to years. Okay, so they're all down there. Something cool. You can just hit this button, fit to data bounds. Automatic zoom level. There we go. I'll just call this listings raw. Don't think there's a lot of reason to do a lot here. We'll just set the symbol the same as we're going to use for the outliers. Okay, great. Completely unreadable, which is fine. So we're going to hide this layer, and we're going to add the outliers layer, and we'll put in a little bit more effort. Okay, so first off, geospatial field is detected. I'm going to say limit to 10,000, so we can see like individual houses. Okay, we can call this layer outliers. Now for tooltip fields, I would add everything we added as a potential influencing variable to analyze. The listing URL, the outlier score, property type, neighborhood also makes sense. And what? Scroll too far. Price. Bedrooms and accommodates. Are we missing one? Maybe so. What the heck? I think I'm hitting refresh on my touchpad. You know, let's just set these accommodates, bedrooms, listing URL, outlier score, neighborhood, price, prop type. Others. Right. Okay. There we go. Okay. All right. Okay. Perfect. So we can see everything that's interesting about that house. Okay. We want to sort them by outlier score because we're limiting how many are displayed, and we want the strangest ones to definitely show up. Okay, so we are going to use the same building icon as before because I like it better. Now the fill color. This is where it gets a little bit more interesting. So we can use the outlier score or indeed the price or, you know, a number of things. And let's use like some super garish display. Okay, great. All right, so we can try exploring that, but it's still a lot of properties. So if we do autocomplete the field name here, if we do outlier score just in the range we're interested in, that should give us a lot less properties to work with. Yes. All right, so let's have a look around. I'm not much mistaken. This should be Koreatown, judging by the shape. That looks like. I forgot to increase the symbol size, so it's for ants. Okay, like this, for example, that's quite a high outlier score. And so that would be interesting to check out. You can already see the price is very high. So this is likely what caused it. You can finally see some of the results of what we have. I've already opened that. I have to wait, and I put in some dates. So this is what this is. So the reason it's an outlier is because you have very high price, only 2 bedrooms, but it accommodates 6 people. And altogether, that's weird. That's not often seen. And you can see like the reason that's the case is just because it's one studio. That costs $1,000 a night. So whoever's keen, you know, that's my trip to NYC next September. Okay, right. So the thing is with this, we could have easily gotten that by just sorting by price descending and bedrooms ascending. Okay, 1 bedroom, but really high price. So that's bad. But yeah, there are easier ways to find this than running all of this. So how about we try to find unusually cheap places that can house more people? So if we have a look further up, I think there's one in Bronx. Yes, if I'm not much mistaken, every one of those. That's an 87 outlier score. Yes, okay, and that's the weirder score. The price is quite high though, again 700. Here though, the price is only 285. So this is our next one. Okay, so I got 15 guests. 2 bedrooms, not so good, but 6 beds, so presumably there's a lot of reception rooms. 1.5 bathrooms, this is more of a spring break kind of thing, I guess. However, it is a very, 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 very cheap, and we're being corona cautious, so set dates, like 5 months, only 4 months in advance now. And maybe this is something that we can go and relax with a large group of our friends afterwards. Now, you could say, okay, well, we've just been looking through listings so far. Like, where's the outlier detection that's been so useful here? Of course, that's what allowed us to filter down. But I find it quite useful at this point to show you the entire data set. And this is just one way to visualize the data, right? Like, you could be looking at a table of this and it'd be the same deal. Well, filter, because the row listings don't have an outlier score. So that's why if you filter by outlier score, then that just filters out all of the row listings. Okay, so this is what it would usually look like. The row listings overlaid with the outliers. And so the more usual use case for this kind of thing, regardless whether you're looking at a table or another kind of visualization, is it just very quickly allows you to notice stuff. I think, due on time, I believe. Or is I'm finishing up. But this one, for example, okay, there we go. Extremely cheap. So we just picked it out simply based on all we did was color in the houses based on the score. And it's amazingly low price. I mean, it's 60 a night for an entire home. So 60 pounds, I guess, for you, be like $80 or so. And it's legit. You can book it. Right. So we've seen quite a bit of what you can do with the outlier detection. Now, if we save this, say, we can add it to the dashboard. Now we can adjust it a little bit. Oh, there we go. And now we can see.
Emanuil, I'm so sorry to interrupt. Okay. It looks like Gonzalo's raised his hand. Gonzalo, do you have a question?
Oh.
Yes, I do. Emanuil, one question that I have about the outlier detection is for which terms does it take into consideration to define it as an outlier?
So in the beginning, when we set up the job in here, so we'll go back from the top so you can see it. So in learning down here where it says analytics, like we have this job here, and when we're creating a job, we tell it where to look for influencing variables. So you pick the raw data as the source, pick outlier detection here, and then there you go. It will look for whatever you tell it here, these fields right here. So what I did was I only told it to calculate for accommodates, bedrooms, like ID is supremely useless, and price. But so this is where you would set that.
All right, but does it detect the outlier based only on the price or based on the correlation between these terms that were selected?
All three of them. So it varies. There is second. If we go to the job display and the other job, should be able to see that. The one that's already ready. And if we show some more columns, where's the outlier score? The outlier score is already in the table. Okay, and let's just make sure that all so the bedrooms, accommodates, and price, they're all on the table, and we'll actually turn off the others. So this will usually tell you exactly which field is having more weight on that. It's the correlation is between all three fields always. But if the fields will have more weighting, that's actually what the table itself is showing you here. Like you see this feature influence score gradient, right? So for this record, it's the price. That's the most important, but there are very light highlights, almost can't see them, on accommodates and bedrooms as well. On this record, it's only bedrooms. This has got, well, it's bedrooms and accommodates in equal degree. Here, it's accommodates the most. So does that make sense? Like it shows you like this visually, which feature is most important. But it's all three. Okay, actually, I'm like totally done with the demo, so that's all good. We've got the dashboard here, and like we're able to see the records, see a breakdown of like what's weird, and we can add different textual fields if we want to see how other fields interact, basically. And of course, the map is a great way to just visualize outliers, but you can pick anything you like, a trend line if you want. For your base visualization. I'm just on the map because I think it's most visual. Right, so.
I think we did have one question from Henry. Henry, did you get your question answered? I see it in the chat.
No, I don't think so. Let's go look. I was going to look at them in a second.
I think it was just the one. If I've been perusing through, I don't see too many other questions.
No problem. Henry?
Yeah. My question is, what is the method the model is using to detect outliers? I mean, it's using, can we set some levels? Because sometimes we want to find more, extreme values. So is there any way that we could set up the parameters in the outlier model? Or is
yes, there, to an extent, you can do so this is where remember trade-off in the very beginning I was talking about a difference between a full pipeline based on Python and something that's like really fast, easy to put into production. So you can toggle what this allows you to do. You can do, so here, if you wanted to set some extra thresholds, just because you know some values, or if you want to limit the analysis to certain values, right? Like, for example, I know that I want to look at extraordinary pricing. So maybe I want to look at pricing that's bigger than 10, just to like get bug records out, and smaller than 100, but also pricing that's greater than $700 a night. So you would set those kinds of thresholds here. As for kind of tweaking how much the model, like how much weight the model puts on something, no, that you can't do. That's why it's, well, unsupervised, I'm afraid. So Yes, you can do whether it's included, but you can't configure the weight. Because the idea with this is that you have like you have some data that you don't know much about, and you just want to see what what is strange. Like you don't know that yet, and you just want to run it through and see what's weird.
Where can I find more, detailed information about the procedure followed by the model to detect outliers? Is there any source of information?
Yeah, absolutely. It's on the slides. So we'll see it. And there's extra resources for this. The code for this is actually, even though it says commercial, the code is actually on the web. It's like just under a license. It means you can't use it, but you can totally read it and learn from it.
Okay.
So if you wanted to see that, yes, 100%. It's
Thank
online. Okay, so let me just check the chat for other questions. Email us for questions. Yep, okay, good. All right, so all right, let's wrap it up. Elastic ML documentation, your first port of call, including for how it works. This actually, the source code repository is not in there. I will paste it in the chat in a second. So yeah, I've sent you to the right place. If you're interested in supervised learning and how that works, this is quite a good blog on language identification at like multi-dimension supervised learning. So you can have obviously like 200 languages. So that feature can have lots of values. It's not just true or false. And then if you're interested in anomaly detection, there's a really short video that's quite good on that by the creator of the entire ML module in Elasticsearch. So I highly recommend watching that.